आज हम एक नए टाइप के रिलेशन के बारे में पढ़ेंगे, नेमली composition of two relations. Okay, so let me have three sets A, B and C. A consisting of X, Y, Z, B consisting of 1, 2, 3, 4 and C consisting of A, B, C, D. Now focus at A and B. Suppose I have a relation R from A to B like this and a relation S from B to C like this. Then this relation give rise to a new relation, namely a relation directly from A to C. We can drop B. Okay, the new relation from A to C is called composition of a relation. So this new relation is going to be a subset of A cross C. How do we define this composition of relations? Basically, we just look at whether there is a path from A to C via B. So if there is a path from a point in A to a point in C via B, then we will relate the element of A to the element of C. This new relation is denoted as SOR, which means composition of R and S. Okay, it is going to be a subset of the set A cross C and it is formally defined in this way. So SOR is a set which collects all the ordered pairs A comma C, provided there is a link between A and C. That means provided there is an element B in B such that A is related to B under R and B is related to C under S. Here I can observe that X is related to 1 and 1 is further related to D. So in the composition relation, I will relate X with D. Also we can observe that X is related to 1 and 1 is not related to B. That means there is no way to reach from X to B. No connection between X and B. So X comma B won't be a part of your new composition relation. Okay. So like this, by looking at the connection, we can define this composition and all the elements of these compositions are like this. This was an easy example. Okay. So finding composition of these two relations was easy, comparatively easy, because there were less elements in these relations. But if there are more elements in the relation, then it is not easy to find the composition in the usual way that we have seen just by looking at the connections. So we have another tool, namely matrix tool. Okay, so matrix helps us to find the composition of two relations. So now we will look at the matrix of a relation. So if there is a relation, there is a matrix defined for that relation. So how do we compute matrix for a given relation? Okay, so let us understand via an example. Okay, so suppose I have a relation R from A to B, where A consists of X, Y, Z and B consists of 1, 2, 3, 4. Then the matrix of R will be of size 3 cross 4. That means there will be a matrix in which there will be 3 rows and 4 columns. Suppose the relation looks like this, then the matrix of this relation is defined in the following way. So there will be 3 rows corresponding to the entries X, Y, Z and 4 columns corresponding to the entries 1, 2, 3, 4. Okay, and then we will just see the first entry which is corresponding to X comma 1. Now in my relation, is X related to 1? Yes, it is related. So we will put 1 over there. Further, the next element is corresponding to X comma 2. Now in my relation, is X related to 2? No, right? So we will put 0 over there. Next is corresponding to X comma 3. Is X related to 3 in my relation? Yes, so I will put 1. And likewise, we can fill all the elements of this matrix. This is the matrix corresponding to that relation. Easy to compute, right? Now, how this matrix helps us to find the composition of two relations? We will use the same example that we have already seen for composition. So, there was a relation R from A to B and S from B to C. So, the matrix related to R was this, which we will be denoted as MR, and the matrix corresponding to S we will denote it as MS. Now we have two matrices, right? The first is of size 3 cross 4 and the second is of size 4 cross 4. Now I will multiply these two matrices. First I will take MR and then MS. Okay. Now after multiplying these two matrices, I will get a new matrix and the size of the new matrix will be 3 cross 4. This new matrix is actually the matrix of composition of R and S. Now using this matrix, we can find the composition relation of R and S. So wherever there is a non-zero entry, we will put that pair in the relation. For example, we can see that the first entry is 1, which is corresponding to x comma a. So x comma a will be member in my composition relation, and wherever there is a 0, we don't take that pair. So that is how matrix helps us to find the composition of a relation. Now those who like coding, they can write a simple code for this, wherein the user enters the relation R and S, and you give the composition relation as an output. We will discuss more example in the next video.